my name is Katie.
My name is Cole.
And my name is Kobe.
And welcome to
the
Couch
Potato Lab,
where we bring the science to you in your own homes. So we have a wonderful episode planned for us today.
Oh no, we've got a friend.
You mean a Dino-Mite episode?
We have a Dino-Mite episode planned today. So go ahead and download that lab manual at bit.ly/couchpotatolab. If you want to text us, you can text us at 306-570-1013. Sorry about that. If you want to reach us on social media, use the handle at @youth on YouTube, TikTok, Instagram, Twitter, or Facebook, and you can use that hashtag CouchPotatoLab if you are using Twitter. All right, so we already saw a preview of what the show is going to be about. So without further ado, let's go ahead and meet our scientists. So to my left, who do I have?
Hello, everybody. What a start to the episode. We are feeling good. We are feeling excited. My name is Cole, and my pronouns are he and him. And I'm very, very excited today because, like Katie said, you did just get a little bit of a preview of what to expect from today's show. And what we're going to talk about today is some people would consider it's a little bit scary. I don't think it's scary, and I don't think you'll think it's scary either, because they're going to be our friends today, not our foes. But that got me reminded me of a childhood fear that I had, and that was bugs, any kind of insects, spiders, or or one of these guys. Whoa! There. Oh, he's gone. Thank goodness. I was scared of. My childhood fear was insects. So yeah. Ooh, spooky. Yeah, that was me.
Awesome. Okay. Thank you, Cole. All right. Giggles are out. We're good to go. All right. Hello, everybody. My name is Katie. My pronouns are she, her, and my fun fact is that I, as a child, was terrified of the dinosaur. What is the name? Megamunch at the museum. It terrified me. I did not want to go anywhere near Megamunch, but I'm over my fear of dinosaurs now, and I'm ready to do this show today. So, who do I have to my right?
Hello, everybody. My name is Kobe. My pronouns are he, him. And since we're talking about biggest fears, my biggest fear when I was a child was the Green Goblin from Spider-Man. I had many nightmares of that because it was scary. And wow, can I pet it? Woo!
Oh,
Go
man.
faster, little guy.
Oh, man.
Okay.
Oh, well, Kobe, yeah. I mean, the Green Goblin, man, that's pretty scary. I would also be scared of that.
Right?
Definitely.
Exactly. The greatest villain of all time, some may say. Before we to start our episode today, we would like to acknowledge that we are on Treaty 4 land, which is the traditional territory of the Nehewak, Nakaway, Nakota, and the Lakota peoples, and the traditional homeland of the Métis Nation. We're so grateful to be able to share this land with these peoples, and hopefully you take the time to recognize which territory you may be from. It may be a different number treaty territory or a unceded territory. So thank you so much for doing that and taking the time and joining us here today at the Couch Potato Lab. Thank you.
Awesome. Thank you, Kobe. Well, as you've seen, we're having a bit of a crisis here because we are not at the studio right now. We have somehow...
Wow,
Katie, careful.
What happened was that we built a time machine. Megan actually built a time machine, and we used it to transport all the way into the era of dinosaurs. And we see a bunch of different dinosaurs today, but our time machine is kind of broken.
It's broken?
It's broken, and we need some
we need to get back.
Yes. Because it's frightening Katie.
Yes, yeah. I mean, there's dinosaurs roaming around. We don't have any idea where we are, and we have a time machine that is broken, and we need to find some fuel or some way to fix this thing. I mean, you can tell that we're getting very emotional about all of this chaos.
I thought you said that we were good with our time machine. I thought everything was okay when we traveled.
Well, I mean, initially, but there is a bit of a problem, Katie. I think we went a little bit too far back, and we actually have run out of fuel.
Oh.
So without any fuel, there's no way to get back.
Okay, okay, that's okay. You know what? We're going to find out a way to get back, and we want you to come along with us, so make sure that you stay tuned throughout this episode. We are going to find a way to go back home. But for now, I mean, I guess we're kind of stuck here for a while, and I'm a little nervous because I don't really know a lot of things about dinosaurs. So, like, do you guys have any knowledge? Like, Cole, do you have any knowledge about these dinosaurs and what we can do here?
Well, Katie, I'm very glad that you asked. Now, I don't have a lot of knowledge about dinosaurs in particular, but one thing I do know about that's sort of related is I'm actually a part-time amateur archaeologist. Now, the reason that is helpful is because using my archaeological skills, I can definitely assume that we're not in a time period where any humans existed, because an archaeologist is somebody that studies human history and human prehistory using things like excavations of ancient human sites, or digging up precious human artifacts from a long time ago and studying them to figure out more about the cultures that might have lived in a certain area, or how old people have been living in a certain area. So with my skill set of archaeology, I can definitely, I've done some digging, and I can't find any evidence of any humans being around where we are. So we must be very, very far back in time.
Yikes.
Yeah.
Okay, well, that is a good indication, Cole. Thank you for letting us know about that. And so, okay, we're in this era of dinosaurs. So, Covey, do you have any expertise on dinosaurs and what they are and what we can learn from them?
Yes, Katie. So we need to learn a little bit more about paleontology. And a paleontologist is a person or a scientist who studies the past life of Earth. And they use fossils to actually learn about it. And why fossils? It's because fossils are evidence that the past life existed. And fossils may have bone parts that might tell what kind of animal or organism, what they may look like, or maybe footprints or imprints to figure out how they actually walked. And this is going to be really helpful on distinguishing different dinosaurs that may exist. And paleontologists study more than just dinosaurs, of course, maybe plants or different animals that actually existed back in maybe 65 million years ago or billion years ago. Yeah, so I might be able to help a little bit with my paleontology knowledge.
Great. Okay. Well, you know what? I feel a little bit better now that I am in great experts' hands. So I think the first thing we should do is, when we're in kind of a new land and we're exploring where we are, we should maybe do a little bit of digging around, maybe a little bit of mining. We should see kind of where we're at and what's in our area. So let's go ahead and do that. So Cole, what are some of the supplies we'll need for that?
Well, so we're going to be digging around, and whenever you're digging around in the ground or a cookie, let's say, you're going to need something to dig with. So there's lots of different tools that you can use. If you were digging in the ground, in the dirt, you might use a shovel or a tiny little pick so that you don't damage things that are in the earth. That's what Covey might use as a paleontologist if he doesn't want to damage fossils. But today we're going to be digging in these cookies, and I'm going to use, my tool of choice is a toothpick. Now, it's a little bit pointy, so if you're using one at home, just make sure you're careful with that. But it's going to be good because I'm going to be able to dig inside my cookie and get anything that I need out. But I know Covey is actually using a different tool.
Yeah, so I'm going to use a skewer. It's bigger, so I can maybe dig out the jewels or the fuels that we may need for our time machine so they can go back home. So I'm going to use a skewer for this, but what else you will need is maybe some cookies. You're going to need a piece of paper. I have graph paper, but you can also use regular paper as well. And you're going to need a pencil. And the first thing I want you to do is, once you have your whole setup set, I need you to draw a circle or outline your cookie. And we're going to talk about why a little bit later on, but let's just do that for now. Maybe outline your cookie with your pencil on the paper.
Well, I've got two cookies here, Covey, so I'm going to do both.
Me too.
I'm going to outline both of my cookies here.
Great. Okay, so I have a question. Does it matter, like, if I have a regular chocolate chip cookie, is that okay too?
Yeah, of course.
Oh yeah, definitely.
Okay.
Any kind of cookie that has chocolate chips or something inside that will eventually be mining out will work. Yeah.
Cool. And why mining is very, very important nowadays is because we need to grab materials and fuels so that we can live in the modern world. And materials are needed for making like your chairs or the highways or the roads. And the fuels are important to power all our technology, like our phones and our homes and our heaters and fans to stay cold and warm whenever it's summer or winter time.
That's right. So Covey and I are going to do a little bit of mining on our cookies. So I'm going to be using my toothpick. Covey is going to use his skewer. And on our chocolate chip cookies, we're going to be trying to try to take out those chocolate chips. And those chocolate chips could represent a lot of different things. But I think in this case, it's representing fuels, the fuels that we need for our time machine so that we can power them. So we're going to start digging through. And Covey, what are what's a good strategy here? Do we want to just kind of go in like without looking and just start hacking things around, or
no? So another part of a mining engineer or miners, what they have to do is reclaim the land, or another process called reclamation, and that is what it means to restore the mined land or the excavated land to its original state. So we don't want to cause a huge mess because we want to make sure that it's back to how it was before, so we're not disrupting the earth too much. So maybe you're going to have to be very, very careful when you're mining your cookies, because if you're maybe jabbing the cookie too much, all the crumbs may be spread all around, and it will be harder to for reclamation to occur. So be very, very gentle. And my strategy is to go around the chocolate chips, and then kind of like digging them out. That's so like going around and digging them out. How about you, Cole?
Interesting. I'm kind of trying a similar thing. But I guess you're right, Covey. We don't want to do too much damage to the surrounding cookie or the surrounding environment. So we want to be sure that we're not, just going willy-nilly in there and getting crumbs all over the place. I have noticed that I've already got a few chips out, but I am making a little bit of a mess. Some of my crumbs are getting off. There's going to be some interesting reclamation going on here.
Yeah.
But again, sorry, Katie, go ahead.
Oh, I was just going to say, it's very important, like, once we get back home, a lot of times we have a lot of mining happening here in Saskatchewan. And I was also just going to say that miners are a very important job, but also mining engineers. So mining engineers will help to make sure that caves and wherever the miners go will be safe for where they go. So that is also a very important job, because obviously mining, it can be a little bit scary at times, and we need to make sure we have the right tools and the right materials, and that we are safe when we are mining. So mining engineers are also a really big part of this. But unfortunately, we only have our miners here today because we are stuck with the dinosaurs.
That is right.
How's your cookie looking, Covey?
Pretty good. I think I got most of my chocolate chips out because that is needed to fuel our time machine. Katie, how much chocolate chips do we need?
You know what? That's a good question, Covey. I put you two in charge of the time machine, and I am not too sure. But if you maybe both get the majority of your chocolate chips out, then I think that'll be kind of enough to get our time machine back up and working so that we can go home.
I think maybe if Covey and I each take out one more chocolate chip,
one more,
that's probably enough, because I already have 6 out.
Good.
And honestly, I'm feeling pretty good about my environment here. I don't think there's too much wrong with what I'm doing. Cool. I think I'm not making that big of a mess.
I got a lot out. It's a little messy.
Okay, I got one more. There we go. All right.
That should be good.
Perfect.
And what you're going to do next is you're actually going to take out your pencil again, and you're going to circle or outline all the cookie crumbs and wherever you touched on the graph paper. And that is pretty much going to indicate how much damage or how much you mined in your area, and how long or what areas of your mining site needs to be going through the process of reclamation once more. So,
so why is that such an important thing to do when we're mining, Covey?
Because for mining there may be different organisms that rely on that specific area, because we are for reclamation, that process includes filling up different holes and with like sand and rock and gravel and then adding a layer of clay and soil so that it is biologically active again, and filling that height or the holes that you made back to its original height so that other organisms can use it once again to continue with their life process.
Great.
Yeah,
okay.
exactly.
Well, that makes sense. So we have our chocolate chips and we're pretty good for our activity. And, you know, I'm just kind of wondering, like, what else are, you know, what is the point of this? Is it, is mining able to provide us any kind of energy, or what do we do with the things that we mine? And Cole, I know that you have some information on that.
I do, definitely. So, like Covey was talking about, when we mine in the ground for fuels, oftentimes the fuels that we're looking for are called fossil fuels. You've probably heard of those before. Now, in the category of fossil fuels, there's actually three main types. So mainly those types are coal, like me, natural gas, and oil. All right. So those are three different types of fossil fuels, but they're all found somewhere in the ground. And we either have to mine for them, or if it's something like oil, we would drill for that because it's in a liquid form for the most part. And then those are used later on to power a lot of different things. So fossil fuels, the reason that they're called fossil fuels is because way back when they were formed, that's kind of what they initially are. So we're going to talk about fossils more later on in the episode. But essentially for right now, you can just think of a fossil was once a living thing, maybe an animal or a plant or something like that. And after it died, its remains get sort of compressed into the earth after a long period of time. We're talking millions and millions of years it takes for fossil fuels to form. But obviously the earth has been around for millions and millions and millions of years, so there's been lots of time for fossil fuels to be made. So the fossil fuels that we're using today were probably made millions and millions of years ago. So after that time, the bones of an animal or the remnants of an animal or a plant or something like that, they're going to get compressed and heated up underneath the surface of the earth. So they're pretty deep inside the earth. And all that compression and all that heat causes the materials in those organisms, be it plant or animal, to start to break down. And when they break down, they sort of get reduced to their simplest molecules. And a lot of the time, hey buddy, listen.
You can't eat our chocolate
Where
chips.
do you get off, man? Come on. I mean, you can't have nothing around here, I guess. This is why we gotta get out of this place. We got dinosaurs coming in, eating my... Jeez Louise.
Oh, man. Okay, yes.
Anyways, as I was saying... oh boy. I don't even know what I was talking about. What was I talking about? Oh yes. So the fuels get compressed, or those remnants get compressed and heated up underneath the ground, and it decomposes down to its smallest form, which is often carbon. Hydrocarbons, combinations of carbon atoms and hydrogen atoms, and depending on how much they're compressed or how much, I'm scared that dinosaur is going to come back, how much they're compressed or how much they're heated up, they're either going to turn into coal, natural gas, or oil. So those final forms of fossil fuels, when we take them out of the ground, we use them for different things. Often coal is used in power plants to heat things up. Fossil fuels are then refined after we take them out, or sorry, oil is refined after we take it out of the ground so that we can turn it into, for instance, gasoline for cars, and natural gas is often used in heating homes and stuff like that, or buildings. Now, obviously, with fossil fuels, they are really good at providing energy, providing power, but they're also very inefficient, and they're also very, very bad for the environment. So when we burn fossil fuels, whether it's the gasoline in our car, or a coal power plant or anything like that, there is going to be a release of carbon dioxide and a lot of other nasty things that are not only bad for our health, but bad for the environment as well. So it's kind of a trade-off with fossil fuels. You do get some energy, but in return, you also get the release of a lot of stuff that's harmful for the environment.
Great. Okay. Thank you, Cole. Thank you for that information. Now, if you have any questions or comments you would like to reach us out, you can text us at 306-570-1013. You can also find us on social media with the handle @EyesYouth on YouTube, TikTok, Instagram, Facebook, or Twitter. And if you are using Twitter, make sure you use that hashtag CouchPotatoLab, and we will answer any of your questions. Okay, so you know what? When you guys were out mining around, and I was just kind of over here exploring, and I'm starting to see like a lot of fossils. And now I know that you're both kind of experts in the field, so I was hoping that you would help me identify what these fossils are, which dinosaurs they belong to. Does that sound okay?
Sounds good.
Yeah.
Okay, cool. So this is my first fossil.
Wow.
It's pretty sturdy, and I'm just wondering if anybody, Kobe, do you know what this is? Which dinosaur would this belong to?
I think that is the horn of a Triceratops. And fun fact about Triceratops is that it's derived from a Greek, the language, and tri meaning three, and keratops means horn face. So three horns on its face, and it's very distinguished or known for its three horns because that is used to attack or like defend itself from the Tyrannosaurus Rex. And they are both from the same era, so around like the Cretaceous period, and they are also known as herbivores. And I think I see one there.
Ooh,
Wow.
A Triceratops.
Pretty scary looking.
So those are pretty big dinosaurs. They can weigh up to like 6 to 12 tons. Yeah, but they have to eat a lot of plants and a lot of herbs and trees and stuff like that, or leaves or berries and all that to get that big.
Okay, so you're saying that this Triceratops only eats plants, right? So it's a herbivore? Is that the correct term?
That is true. It is a herbivore, so it only eats plants and not any meat or other animals.
Okay, well, I mean, I guess that's good news for us. It's not going to go and have us for lunch or anything.
Nope.
Okay, well, now I have another fossil, and this one is it's kind of coming apart now because we're looking at delicate things, just like fossils, they come apart, and we have to be careful when we're handling them. But Cole, I was wondering if you know what this one is.
Yes, that does look very familiar to me. I know a Stegosaurus spike when I see one, and that is definitely one of the spikes from a Stegosaurus. Now, a Stegosaurus is similar to a Triceratops in that, again, there's a picture of it. It is a herbivore, which means it eats plants. And in that image, you can see those sort of orange-greeny, sort of spiky, spiny things along the back of the Stegosaurus. That is what Katie found in her fossil there. So a Stegosauruses were found around 150 million years ago. And like I said, they're herbivores, and they were actually really, really big. So you might not be able to see from that image. You can't really tell. But for context, Stegosaurus is like as big as a bus. So they're very, very large. And again, like similar to a Triceratops, they are herbivores. They're not going to hopefully harm us around here. I don't see any, but who knows? The way that this is going, we could have dinosaurs come, at us from all angles at any time. So, but hopefully, if it's a Stegosaurus, we should be okay because they don't eat meat. So.
Okay,
we should be good.
Great. Yeah, so far I'm liking these herbivores. They're great. So this is my next fossil I found. It kind of looks like it's very kind of bony. And Kobe, do you know what this one is?
I think it kind of looks like the club of an ankylosaurus. And I think I see one over there. But yeah, there it is, the ankylosaurus. So at the very, very end, or its tail, it has a big kind of like a club or like a boulder kind of thing. And that is used to protect itself. So it might use it to like whip other dinosaurs so it goes away or anything like that. But ankylosaurs are herbivores as well. And they are also, in the Greek name it's derived, it's known as the fused dinosaur, and that is because the bones of its skull is actually fused with other parts of its body, so that it kind of looks like it's it's wearing a plate of armor, and it's very, very rigid and really, really strong. And this ankylosaurus was also in part of the late Cretaceous period as well. So we may be in that time period where Triceratops also exists with it, and its favorite Tyrannosaurus Rex around.
Wow. Yeah. Wow. Okay. So still a herbivore, so I guess that's okay. But I did find one other one, and this one looks a little bit different.
Oh no.
It kind of looks like a tooth. Is that right, Cole?
Katie, oh no. I think we're past herbivores now. That to me looks like a tooth from a Tyrannosaurus Rex.
Uh-oh.
Yeah, that's right. T-Rex himself, a Tyrannosaurus Rex. They are considered to be the largest of the dinosaurs, and they are not herbivores. They are carnivores. They do eat meat. Very scary individuals. But I think if we play our cards right, we should be okay. Now, a Tyrannosaurus Rex, again, they're considered to be the largest type of dinosaur that there ever was. And for sort of scale, their jaw, so the jawbone in their mouth was about 4 feet long, which I think is like around the size of this table here. So that's a very, very big jaw. And that tooth that you showed, they had very, very sharp teeth because, again, carnivores are going to have different teeth from a herbivore like a Stegosaurus or a Triceratops because they don't need to just eat plants. They're going to be needing to tear through meat and animals and stuff like that and other dinosaurs. So Tyrannosaurus Rex tooth, definitely a little bit scary. We should be careful.
Yikes. Yeah, definitely going to be looking out for those guys around here. So, you know, as you were kind of explaining about those fossils, of course, I was taking a look at my homework because I am currently in a dinosaur class. And there's only one thing that I can conclude from all of this is that we are in the Mesozoic era. Do you guys agree?
I mean,
so.
I think so. Based on the fossil evidence, I would agree. Mesozoic.
All right, so if that's where we are, then maybe let's go ahead and let's take a closer look at this Mesozoic area. I'm going to go and pull this board up a little bit. Now, you might not have heard of the Mesozoic area, but you would have heard of the periods inside of this Mesozoic era. So let's go ahead, and it's separated into three periods, some of which are actually made into movies. So the first period we have is the Triassic. So in the Triassic era, we had Pangaea, which is one single landmass throughout the entire world. So right now we have different continents. We didn't have that back in the Triassic. We had one single era, or one single landmass, sorry. Okay, at the same time, we had reptilian dinosaurs. So we had those ones kind of wandering around the Earth because we had a very hot temperature at that time. So a lot of the other dinosaurs couldn't survive at that moment. So it was only those really hot dinosaurs that were kind of roaming around the area at that time. Our second period is the Jurassic period.
Jurassic.
I've definitely heard of that one. That one sounds very
like
familiar.
the movie. Katie, if you don't mind, could you use a different type of marker? It's a little hard to see.
Okay, for sure. Okay, so the Jurassic period was found in, just like the movies, as you said, Jurassic Park. Now, this is where our first mass extinction came from. So scientists don't know yet why it happened, but there is a huge mass extinction and it wiped out a lot of the dinosaurs. So the dinosaurs that prevailed and survived that mass extinction were the large herbivores. So they started to kind of roam around the Earth and temperatures cooled down a lot. So now our final period, I'll use a different color here, was the Cretaceous period. There we go.
Oh, that's where most of our dinosaurs actually came from.
Exactly.
Like the T-Rex and Ankylosaurus, Stegosaurus, Triceratops.
You're right, Kobe. So the Cretaceous period included a lot of the dinosaurs. It was kind of the peak area of the dinosaurs. And what happened was Pangaea, when it split into many, many lands, so that's what we have right now. We have many continents all over the place. We don't have a single landmass. When that happened, our organisms diversified, and we got a lot of different types of plants and insects. But there was another mass extinction, and there was a huge meteor that came and wiped out many, many of the dinosaurs. So the only dinosaurs that survived that mass extinction were the small dinosaurs and those dinosaurs that could fly, which we're going to talk a little bit about later. But a lot of the dinosaurs were then extinct. So that is what happened. And, you know, I'm kind of thinking about this, and I'm very interested in this meteor and how exactly it wiped out the dinosaurs, because a meteor is just like a big rock that hits the Earth. So how could that one rock wipe out an entire group of dinosaurs? So I think we have a little bit of a demonstration here. So I'm going to pass it off to Cole, and he's going to talk about this.
Definitely, yes. So, like Katie was saying, one of those mass extinction events, we have very, very good evidence to say that that was caused by a meteor impact on Earth. Now, a meteor is essentially, you just think of it as like a flying ball of rock and ice and maybe some gases and dust particles that flies through space. And meteors are everywhere through space. But because space is so big, we usually don't have to be worried about them here on Earth, because we are kind of just a tiny, tiny dot compared to how big space is. So most of those meteors are going to fly right by us and we'll be totally fine. But millions and millions of years ago, the dinosaurs got very, very unlucky, it looks like, one day with a meteor. So Kovi and I are going to do a little bit of a demonstration. We both have a paper towel here that just has some flour on it, and we spread that out nice and thin. And over top, I'm going to put some dirt. And Kovi's doing that as well. I actually have sand, I guess, but dirt would work as well. And you're just going to kind of spread that on top. And this is going to represent the surface of the Earth. So we've got sort of, I guess you could say sand and dirt maybe it's a little bit harder almost than flour, Kovi.
Yeah, so like since the flour is like the dust particles, it would be a lot lighter. So the sand or the dirt would be a lot heavier particle, and it's usually up top. So this is how it's going to be represented for our Earth, and we're going to make it nice and flat so that when we simulate some meteors falling onto Earth, we can see the impact and craters that might be formed when the meteors land.
That's right. Yeah. So, Kobe and I are going to do a demonstration of why the meteor that took out the dinosaurs was such a big deal. Because actually, Earth is struck by tiny meteors all the time. All the time. Very, very tiny ones. And we're going to do a demonstration of how that size really makes a difference with what the impact is on Earth. So I have here just a really, really small rock, and Kobe has a larger rock, okay? And we're going to use that to simulate a meteor. And all I'm going to do is drop it down onto my simulated Earth, and we're going to see what kind of impact or what kind of crater we get out of that. So, Kobe, are you ready?
Yeah.
Here we go. I'm going to drop mine.
Ooh.
There you go. So, I don't know if you... Maybe I'll do that one more time, too. Closer to this side. Okay, and if I take it out, there is a little bit of a crater. There's a little bit of a hole, but honestly, compared to how big my Earth is here, not too big of a deal. But Kobe, I think your rock might do a little bit more damage.
Yeah, so I have a bigger rock, and I assume that a bigger rock will cause a greater crater formed because remember that gravity acts on the weight or the mass of objects and is going to pull rocks and stuff like that to the surface of the Earth. And hopefully, I think it's going to cause a big crater in 3, 2, 1. Oh, oh, that big point.
Holy moly. That's some damage right there.
That's a big damage, yeah. So I think, Cole, do you have another rock maybe a bigger rock by chance?
I've got, well, let's see. How big was yours, Kobe? I can't.
About this.
Okay, I got one about that size. I think this one's a little bit thicker, though. So should I try it?
Yeah, let's try it.
Let's see if I can give it a shot here. So again, bigger meteor. Let's see what kind of impact this guy has. Whoa!
Wow.
Big impact. And we got some of that dust that Kobe was talking about spraying out. So let's try that one more time. Big impact again. So we can see that the size of the meteor really, really matters in this case. Now, the meteor that came and took out those dinosaurs all those millions of years ago would have been a very, very big meteor. Big enough to not only where it hit would have made a big crater, it would have anything around it would have been wiped out very, very quickly. But there is more to a meteor hitting the Earth than just the initial impact. There's some lasting problems that are going to happen. So when we dropped this, we saw some of the flour that we considered to be dust fly out. Kobe, why is it really bad if the dust flies out?
Oh, it's bad because if the dust is flying out, it kind of makes a screen or something like that, and the sun is not able to get past that screen, and maybe the plants on the other side of the screen may be unable to get that energy from the sun, so photosynthesis may not occur. That means that they might not grow, and dead particles will be formed on the other side of that screen. And I think, Katie, are there other possibilities that might happen as well?
Well, I know that kind of after that cooling also came global warming, and it really heated the Earth. A lot of the organisms died because of the fire, and so that is exactly why only those small little creatures survived, because they were able to kind of dig themselves into little burrows and protect themselves. Also, the flying dinosaurs were able to obviously live in the air, and so they were okay as well. So that's very interesting how all of these dinosaurs, some of them lived, some of them didn't, and all of this dinosaur talk is getting me thinking about more questions. So if you have any questions, make sure you are texting us at 306-570-1013. You can also reach us on social media at Eyes Youth on YouTube, Instagram, Twitter, TikTok, and Facebook. If you are using Twitter, make sure you're using that hashtag CouchPotatoLab, and we will get to all of your questions. Such as this wonderful question that we have from Rhythm here. And Rhythm is asking, how many types of dinosaurs are there? That is a great question, Rhythm. Kobe, do you know the answer?
Yes, Katie. So there's about 700 dinosaurs that were discovered around the world, and paleontologists have discovered that there is about over 700. So over 700 is the answer.
Wow, that is incredible. There's so many different types of dinosaurs. And, you know, when I'm kind of thinking about that, I'm also thinking about our fossils that we were looking at. And I thought that maybe we could get into an activity where we're actually going to make our own fossils. So we're going to be able to imprint stuff in our fossils and create little fossils of our own that we're going to be able to explore later on. So let's go ahead and see what our scientists are doing. So, Cole, what do you have there to make our fossils?
So you're going to need just a few ingredients to make the fossil. So the first thing you're going to need is some flour, which we have flour down here. And then you're also going to need some salts, and you're going to need just water, okay? And I think Covey might be grabbing some water right now because I don't have any here, but we're going to get some, and that will be good. So the first step is you're going to grab a big bowl so that you have a lot of room for what you're going to be doing. We're going to add 2 cups of flour into our bowl, okay? So again, what we're doing here is we are making the molds for our fossil. So we're going to imprint our fossil inside of this mold that we're making.
Okay, that looks pretty cool. And you know, Cole, I was kind of baking some cookies the other day, and I was using those ingredients. So is it okay for me to eat these fossils when I'm done with them?
I would recommend that you do not eat these fossils, actually, just because they're definitely not going to taste very good. And also, it's a general rule that whenever we're doing science, we normally don't eat science. So even if these are baking ingredients, you might recognize them, like flour, salt, and water. We don't want to eat this. And the other thing is because we're going to be using things to imprint the fossils in. We don't know where those have been. We don't know where our ingredients have been. So for this experiment, we're not going to be eating. We're just going to be looking. So I've got my 2 cups of flour inside here, and I've spread that out. And then I'm going to add my cup of salt as well. So I already pre-measured this. So a cup of salt going in there. I'm going to just mix that up with my hands.
Okay, that looks pretty cool. So let's go ahead and see, Covey, where are you at in our stage of fossil making?
So I am done, and let's talk a little bit more about how fossils are formed. So here is a little picture of how fossils are formed, and that really depends on how rocks and all the organisms, when they die, they are on the surface of the earth, and then they are eventually buried from layers and layers of different sediments, and that causes a lot of pressure, and that because of the pressure, it kind of imprints on the rocks, and rocks are formed, and thus we get fossils. And that is how fossils are formed. And today, when we are making our fossils, we are going to actually put a lot of pressures on our imprints, like maybe our leaves or maybe dinosaur footprints or anything like that, when we are making our fossils, because that is pretty much the main mechanism on how fossils are formed. And not just dinosaurs, there are fossils of different animals as well. So like fish, for example, and here's a picture of a fossil, a fish fossil, and you can see all its bones, and you can see the skull of the fish as well. And you can tell that there is a lot of pressure on that rock, right? So the layers and the layers and the layers of sediment, that pressure is applied and imprinting all those bones onto that rock.
Interesting. Okay. Well, when you were kind of saying about like applying pressure and stuff, I was kind of watching what Cole was doing. And Cole, what are you doing with our experiment right now?
Well, so now that we have all of our ingredients all mixed up, I'm kind of just kneading it around. You're going to notice that it turns into like almost like a bread or like a dough, basically, is what we're making. And you want to mix it all up. So I've got it all in a big clump, and it sticks together pretty well. You want to keep it nice and sticky. So I'm wearing gloves just because I don't want to get my hands all messy, but if you want to go in there without your gloves on, you should be okay. But again, we want it to be solid enough that it sticks together, but soft enough that we can actually make imprints in it, like Covey was talking about with real fossils. And actually, there's another thing I wanted to mention about fossils I think is interesting is not every animal or plant gets turned into a fossil. So not everything doesn't necessarily become a fossil. There are lots of fossils, but that's just because there were lots of animals and lots of plants over the history of the Earth. So not every single thing becomes a fossil after it dies. Only certain things do, and it really depends on the specific conditions that are necessary for fossil creation, like that pressure and that heat and that kind of stuff. So we've got our Covey. How are you doing? You got your ball of dough, of fossil dough, ready to go here?
Yes. And the next thing what you're going to do is maybe take a portion of that ball of yours, and we're going to make a kind of like a really thin cookie, pretty much. Like a really, really thin, small circle. And we figured that the thinner the cookie is, or your circle, the easier or faster it's going to bake. And I'm going to maybe thin it out just a little bit and place it on our table. And the next thing is we are going to make our imprints. And I brought some leaves of a plant to make my imprint. And you're going to place it on top of your dough cookie or anything like that, and then maybe apply some pressure.
Okay, that's cool. So we're using leaves here, but are we kind of able to make anything into a fossil as long as it fits onto our dough?
Yes, that's right. You could make anything into a fossil. Really, this fossil dough is just being used as a mold, but it's the exact same process that we would normally have in real life of this imprinting, this compression. So in real life, instead of Covey and I pressing down with our fingers, obviously that represents the weight of the earth that's kind of pressing things down and compressing it in the sediment over time. So you want to make sure you get it in there, but you don't want to press so deep that it just goes through the other side or you get it stuck in there. But you want it deep enough so that you make a nice imprint. So when you take it out, like I'm going to do very carefully. It might be hard to see on camera, but you should maybe a little bit be able to see the outline of the thing that you were making with the fossil. So I have a little bit of my 3-leafed kind of plant imprinted into my fossil.
Oh, that is cool. And you know what? Both of those are looking really cool. And I see, Covey, that you're also using something else for our fossils.
Yeah, so I found a small dinosaur bone, maybe from one of the dinosaurs that we saw. And I'm going to make a cool footprint. A dinosaur footprint. And
I'm going to try that too. I also found one. I think we took both of this dinosaur's legs, which is okay, so it shouldn't be bothering us anytime soon. But again, the same kind of principle. You want that nice and thin, and just pressing that footprint in. Not too deep. There you go.
That is interesting. And I know I was kind of like looking ahead, and I know that the next step we are going to have to bake these fossils. So if you need help, then please make sure you are asking a parent or guardian for help when you get to that stage of baking our fossils, because it does take a little bit of hard work to do that. And so make sure you are asking for help if you do need that. So we have some pretty cool fossils so far.
Definitely.
And what would our next step be, Covey?
The next step is using your oven. So what you're going to do is preheat your oven to about 200 degrees Fahrenheit if they're really, really thin. And you're going to put it in maybe like a baking sheet. I thought that maybe putting butter or some like Pam or some oil on our baking sheet so our cookies or fossils don't stick to the pan. And you're going to bake it for about maybe 30 to 40 minutes if it's really nice and thin. And if the thicker it is, the harder it's going to bake. So thicker cookies would take about like 3 hours, 2 hours. So make sure you make some really, really thin ones.
Oh, we need some patience with our fossils here, it looks like. But I know that, you guys have some bit of magical powers. Of course, that time machine kind of wore off on us, and it gave us some of those magical powers, and that we are able to bake those fossils a little bit faster. So let's take a look at the fossil that you have, Cole.
Yes. So, and again, it is definitely there. It might be a little bit hard to see on camera at home, but here is my finished leaf fossil. I'll try to, I don't know if that's going to help or not, but what you can see from my angle, you should be able to see a little bit. You should see some like those deep lines. Now, when we bake the cookie, that's like the heat of the earth baking that fossil. Okay, so we did the compression, then we add the heat, and that really sets everything into stone, literally. And that means that we've got these imprints here of where our leaf used to be. Very cool.
Wow, that is pretty cool. And Covey, I also know that magic power rubbed off on you as well. So what kind of fossils do you have?
I have my little leaf imprint as well. It's a lot harder now. My cookie is like, I should stop saying cookie because we're not going to eat it. But our fossil is nice and hard. And we can see the imprint. Ooh, yeah.
Nice.
So you can see the outline of the leaf, and maybe you can see the veins or all that. So nice. So
that is interesting.
That is how fossils are formed.
Awesome. So if you want to go ahead and give that experiment a try, please do, and then let us know how it looks, because we would really love to see those creations. So, as our experts were making our fossils, I was also kind of thinking a little bit about birds as well. And why would I be thinking about birds? Well, not sure how many of you know this, but birds are actually dinosaurs. Now, why do I say that? After the meteor struck, those smaller dinosaurs and the flying dinosaurs survived. Now, what scientists have discovered is that modern birds have the same type of bones as flying dinosaurs. So we have a little bit of a graphic here we're going to show, and it's basically showing what the bone of a human looks like compared to what the bone of a bird looks like. So you can see that a human bone is much more compact. There's a lot of stuff happening. It's very dense, whereas a bird bone has a lot more air in it. And when scientists looked at the bones of birds and looked at the fossils of flying dinosaurs, they saw that both of those bones had the same type of bone, that it was very airy. It was not dense like human bones. So we know that birds were actually kind of the ancestors of these flying dinosaurs, which is really cool. So if you look outside and you see a bird, you can say, hey, that's a dinosaur. A little bit.
Wow, is that a dragon?
Look at that thing.
There we have one right there. Go away.
Oh.
I heard dinosaurs actually have feathers. Yeah, there has been some research or some exploration from paleontologists that dinosaurs actually have feathers, and feathers are actually very important for keeping the dinosaurs warm. So even though some dinosaurs may not be using it for flight, they will be using it for like camouflage or for warmth and stuff like that.
Yeah, exactly. Yeah, and those dinosaurs, the flying dinosaurs, were called theropods. So those are very interesting, and it's great to see so much active life around here.
It really is.
Yeah.
It really is, yeah.
All right, so we are nearing the end of our show, so make sure if you do have any questions or comments, please text us at 306-570-1013. You can also reach us on social media at EyesYouth on YouTube, Instagram, Twitter, TikTok, or Facebook. And if you are using Twitter, make sure you use that hashtag CouchPotatoLab. All right, so we have learned a lot about dinosaurs so far, and you know, I am very fascinated with the different kind of bones we've seen and the fossils that we made and the dinosaurs that are around here. And I thought that it would be kind of fun, before we go back to our time, to take a little bit of what we've seen today back. So I thought that we could do a little bit of a science showdown. Great. Okay, so what we've done is I have given our scientists dirt, and within this dirt is going to be different fossils. Now, these fossils will actually create a dinosaur that we're able to bring back to our own time. So, in your buckets of dirt, I have given you these fossils. There is 9 fossils in total. They are different dinosaurs, so they are not the same dinosaur that you're building. And what we're going to do is the first person to dig up all 9 of their bones and properly assemble their dinosaur is going to be the winner of our science showdown. How does that sound?
Sounds good. Kobe's going down.
I'm ready.
Kobe is going down.
Oh, I heard that like our boss Megan has a like revival machine that might be able to revive the fossils.
Oh,
if we
really?
Yeah, if we could construct it like
well,
real
I'm sure
fast. Right.
I'm almost positive it will work, actually.
Oh, you know, I'd love to see some more of those dinosaurs. All right, so let's go ahead and let's start our science showdown. Let's give a countdown in 3, 2, 1.
He started before. Kobe had a bone out. Okay, that's fine.
Okay,
start digging now.
Okay. I got 3.
Okay, ooh.
All right, so remember, there's 9 dinosaurs in total.
Ooh, I see some spikes, and I think mine might be a stegosaurus.
Okay, I have a good clue here. I've got this Triceratops horn. I'm pretty sure that's what that is. Excellent. 9, you said, right, Katie?
Yes,
1,
there's
2,
going to be
3,
9 in total.
4, 5.
3, 4,
Oh,
5,
yeah.
6.
Definitely a Triceratops, I'm going to say.
And you know what? As our scientists are going and they're kind of digging up all these bones, looks like they actually have a pretty good start. So they're going to start assembling these fossils pretty soon. But I did want to give just a few honorable mentions to some of the dinosaurs that we've seen around here today. So we have an image here that we're going to show everybody, and we can see some of these dinosaurs that we've actually been seeing as well.
Whoa! So the top left, that's a plesiosaurus. So that's like a dinosaur that lives in the water and has those flippers, kind of like the marine animals that you may see, and that aids with swimming. And then there's another one right next to the plesiosaurus to the right is a brachiosaurus.
That guy better watch out.
Oh yeah,
he's standing underneath. He's standing in a very vulnerable position.
I mean, that was us.
That truly was.
So.
I think I have a lot. Anyways, that brachiosaurus, it has a really, really long neck, and Katie, any guesses? Do you think it's a herbivore or a carnivore?
Oh man, you know what? I always thought that the scarier looking dinosaurs were the carnivores, but it looks pretty scary to me. But I think that it might actually be a herbivore.
You are correct. So that Brachiosaurus is a herbivore. Let's take a look a little bit more of the other two dinosaurs that we've seen so far. Ooh, Katie, you talked about some flying dinosaurs like theropods. What dinosaur do you think that flying one with the wings
All
is?
right. Well, I actually know this one, Kobe. This one is called a pterodactyl, and I know that because it has a weird spelling. It's actually spelled with a P. It's PT,
Wow,
right?
it's a silent P.
Yes.
Weird.
Crazy. And Cole, what do you think the last dinosaur, the really tiny one at the bottom?
Can I see that image one more time? Let's see.
Yes.
Oh, the bottom right.
Bottom right.
That looks very familiar to me. I want to say that it's named after a basketball team, I want to say.
Oh, yeah.
Is that true?
You are correct.
I don't know which came first, the basketball team or the dinosaur, but that looks like a velociraptor to me.
That is
A raptor.
correct. A velociraptor, yes. And any guesses if it's a carnivore or a herbivore?
Oh, I know for sure that guy is a carnivore.
Yeah, so that velociraptor, boy or girl, is a carnivore indeed. So it eats meat, and it has ferocious teeth that can shred and tear its prey. And it kind of like, I know that multiple velociraptors, because they are smaller in size compared to the T-Rex, they maybe like a pack or a squad of them will be required to actually defend themselves against a T-Rex that might be attacking them. Yeah.
That is pretty cool. Well, you know what? I am quite impressed with you guys because you are building those fossils really, really quickly. Cole, how are you doing?
I'm almost done. I am putting on the tail, and I have assembled the skull of the Triceratops, and I just got to click it on, and I think I'm good.
Oh,
What?
Kobe, how are you doing?
I'm not.
I think Kobe was a little too focused on giving us very good information on those dinosaurs, where I'm pure speed, and really, I'm scared I'm gonna break this, but you know what I have to do is I have to reset here and do
Oh
this.
yes, the order
like
is
this.
very important.
Yes, I didn't know. I didn't even think of
I
the
don't know
order.
how to put this together.
This is actually a little bit more difficult than I was anticipating.
And so, Cole, you said that you have Triceratops, right?
I'm 99% sure. certain,
Okay, so
I'd say.
Kobe, what do you have? What dinosaur do you have?
I'm pretty sure I have a Stegosaurus. So I remember when we were talking about those spikes on its back, right? So those would represent the Stegosaurus as well. Yeah.
Oh my goodness gracious.
Katie, what's your favorite dinosaur?
My favorite dinosaur is the long neck. And yes, I know that that is not the proper term for it, but my childhood was full of Land Before Time. Still today, Land Before Time is great movies. If you know Land Before Time, let us know because that is a great movie.
Mm-hmm.
What was your favorite dinosaur, Kobe?
My favorite dinosaur was the Ankylosaurus. I think it's so cool that it has like a weapon as a tail.
Yeah,
Or-
well, glad we didn't see any of those today. You know, that could have been bad.
That would have really derailed the
Will
show.
we might be able to see it eventually? I know that we saw some velociraptors trying to eat Cole's cookie.
That was,
Oh, yeah.
I without a doubt, the most shocking experience of my life. And I say that with complete sincerity.
All right.
Okay, Katie, you know what? I'm having difficulty because I definitely have constructed everything.
Uh-huh.
I know that it's a Triceratops,
Okay.
but I'm just having a lot of trouble getting the pieces to stay on.
Okay, well, you know
And
what?
like I could do this and
Yeah.
just sort of balance
Okay.
this on there, and then we see. Look
Yep.
at that. That's a Triceratops.
Okay, you know what? I'm gonna give the science showdown to Cole then.
Yes.
Because he has all of the fossils and he showed me a completed fossil image. So that is really good work, Cole. Well done.
Better luck next time, Kobe.
Wow.
Archaeologists win again.
No, I just finished my. Look at this. Look at this.
That's also pretty good. That's
Kobe,
also
you
pretty
did
good.
you did pretty good. You get an honorable mention for doing that. As
You
well.
can go
Well,
on the
we-
list of
we-
honorable mention dinosaurs, Kobe.
Yeah. Nice. I'll be right in the middle.
All right, so this was all a really fun science showdown, and you know this also got me thinking that back in our hometown Regina, we have the largest T-Rex in the entire world, Scotty, that is at the the museum. And so whenever I think the museum is open now, so when it's safe to do so, you can go ahead and look at Scotty. It's the largest T-Rex in the world. We just beat out Chicago for that. So that is pretty cool. Regina has some pretty cool stuff. At the same time, we know a lot of people that are working at the museum, and a lot of them are looking at these fossils, and they are exploring what we have. And one of these people, they're called Dr. Emily Bamforth. And so we're going to go ahead and take a look at that STEM Spotlight right now.
On today's STEM Spotlight, we would like you to meet Dr. Emily Bamforth. Emily is currently a paleontologist with the Royal Sask Museum and has her PhD in paleoecology and paleobiodiversity from McGill University. One day in her 4th year of her undergrad, she missed her bus heading to school and had an extra hour to kill before the next bus came. Wandering the halls, she stumbled across a poster for a lecture on fossils that she was interested in. She went in, introduced herself to the professor, and next thing she knew, she was doing her master's thesis with that professor at Kingston University. What incredible work, Dr. Bamforth.
Great. Okay, so thank you for all of that work.
North America, and that is our conclusion so far, and that's what paleontologists have found.
All right, thank you, Kobe. All right, so those are some great questions, and you know what? As much fun as it's been here, I really think that it's time to wrap this up, and we should get home. What do you guys think?
I agree.
Yes.
I need to get out of here before those dinosaurs come back, because I do not know if I will be able
I just want to
survive.
see like at least one before we go.
No,
That'd be really
I
cool.
think it's time. We need to go now. We have our chocolate chips, and we are going to travel back to our current time. But for now, we will leave you on this part of our episode. So thank you so much for joining in. We had a really great time with everybody learning about dinosaurs.
There it is. Hello.
There they are. Right?
You
know what?
T-Rex is a T-Rex
It's
coming.
great. It's so graceful the way that they move.
It's so slow.
That's a really great image.
Maybe we'll see that dragon again.
That's great.
Flying around.
Great way to end the show. We're gonna go before we see any more dinosaurs.
Yeah, really.
T-Rex.
Really.
All right. Bye.
Bye.